Yeah. Yeah, right? No, that's their loss. Okay, let's go. Okay, guys, we're back. Okay, so here are some terms or notation we need to know. A sub n is asking for a specific term. Okay? So if I want like a sub 7, I want the 7th term. Okay? So let's say my n is 7. I want a sub 7. What would a sub n minus 1 be then?
6?
Yeah, so this is just saying I want the previous term. Right? So if n is 7 and I'm asking for a sub n minus 1, then I want the term before the 7th term. You with me? Yeah. And then a sub 1 is called my term 1, my first term, my start.
That's the initial term.
Right. It is.
I barely remember.
We came to math, and you're like, okay, does everyone remember this? And we're like, no, there's no 3.
Oh, I remember. You guys had a panic attack because I asked you to find the area of a circle. Write an equation. All right. Listen up. Listen up. Shh. Okay. We're going to write an equation now, a formula for our sequence on the other side, okay? So if I want to find a specific term in a sequence, and this is the sequence from the first one, you guys told me that I just add 3 every time, right? Mm-hmm. Add 3 to what? To the previous term, right? Well, now we have notation for the previous term. So could you build me the whole sequence from the other one now?
Yeah.
No, you couldn't. What are you missing?
The base.
What the base is?
Where I start. How do I know what to add 3 to for the first term, right? So part of my sequence formula is always listing the term 1. This is called a recursive formula. But it's just, think of it as, it's just the formula to represent the sequence, right? You give the first term, right? Now this formula here, can you see that it doesn't work for the first term? Because if I plug 1 in for n, a sub 1 equals a sub 0 plus 3. But it doesn't matter that it doesn't work for the first term because I give you the first term, right? But it works for the second term. So a sub 2 is a sub 1 plus 3. You with me? Anyone have any questions so far? Okay, so now let's write one for this one. First part of my formula is I have to have my first term, 1. So I know where to start, right? Then to get the next term, you take the previous term and do what? Times 3. Good. We're doing okay? Okay. I want to know if this number 1 here is arithmetic, geometric, or neither of those.
It's geometric.
Why?
Because there's an exponential growth.
It is geometric, but what do you mean exponential growth?
Oh, it's like multiplying a certain number.
Very good. So it's times by 5 each time, right? So let's write that it is geometric. Then let's write its formula. So its formula would be a sub 1 equals 2, and then a sub n equals the previous term times 5. Okay, what about 3? I'm jumping. What about 3? Is that arithmetic, geometric, or neither? Arithmetic. Okay, so now let's write its formula. A sub 1 is 22. You have to have the first term with your formula, or else how do I know what to start with, right? And then what am I adding each time? Good. So a sub n is a sub n minus 1 plus 9. What about number 5? I am multiplying each time. Aren't I multiplying by 2, then times 3, then times 4?
Isn't that something else?
It's totally something else. If it's geometric, it has to be the same thing each time. So this one is neither. It's not arithmetic or geometric. It's just something else. Not every sequence is either arithmetic or geometric, right? Well, those are just the ones we're focusing on today. Try 2, 4, and 6 with your neighbors. If they're either arithmetic or geometric, give me a formula.